Hi, everyone, and thanks for coming to my talk today. I'm Johann Wentzel, and I'm a PhD candidate at the University of Waterloo, and I'm here presenting SwitchSpace, Understanding Cross-Reality Peaking Between VR and Desktop Interfaces. I finished this project with the help of my co-authors, Fraser George Fitzmaurice, Tovi Grossman, and Dan Vogel. So, mostly as a commentary on my own attention span for presentations, I'm going to summarize our findings here. First, switching between VR and desktop happens often, but it can be cumbersome. Talking with people who use both, the act of switching between VR and desktop can make these workflows harder. Second, as a remedy, techniques that let you quickly and temporarily peak between the two can make these workflows faster, more precise, and more comfortable. So now I'll explain more for the rest of the presentation. So it might not come as a surprise to you, but moving hardware around is hard. If I was a VR developer who needed to make a bunch of tweaks to Unity, for example, I'd have to completely take off the headset, put down the controllers, and find my mouse and keyboard to keep going. Likewise, going from desktop to VR can be just as difficult. This transition isn't just about changing physical devices, it's about the mental shift required, which can often disrupt the flow of work. So this kind of issue lies in the purview of three pretty related areas. So first, there's real virtual alignment, which brings to mind Desk VR, a system where the user's real and virtual desks were aligned. Next, the idea of using 2D interactions in 3D, which solutions like Symbiosis Sketch have explored. And likewise, we've also got 2D, 3D transitional interfaces, which Carvalho tested out using a monitor, a Wiimote, and a Cave VR system. But what we aren't really seeing is work specifically examining the usability implications of transitional interfaces between VR and desktop. So as an initial exploration, we started it with a formative study of 24 VR users. We found that people preferred using VR over desktop when they wanted to feel more immersed or needed better 3D understanding of their content. Likewise, people preferred desktop to VR for added precision, like that of a mouse, as well as for convenience and the ability to complete multiple tasks at once. Talking about transitions between VR and desktop, we found that this often happened in rapid prototyping tasks like writing code, previewing 3D models or environment, or other tasks like that need those kinds of quick back and forth switches. So we learned kind of two primary things from this. First, these transitions, while discomforting, were quick and they were temporary. People would switch from a primary modality, think VR for example, to a secondary modality, in this case desktop, then back to the primary. It's a quick peak from one to the other, then back to the first. Next, these peaks are primarily within a single mode of use. It decouples input from output. People would primarily just put on or take off the headset or grab the mouse quickly to make tweaks without having to put on the headset. One participant we talked to as an example for why they transition between VR and desktop, they mentioned, I transition if I need to tune the scene or visualization parameters so that it's this constant VR and non-VR change, which really motivated a lot of our work. So we took the findings from the formative study and summarized them into a definition of context, which for us combines three elements. First is input, so the input device they're using, like controllers, a mouse, or a keyboard. Next is viewing, how they're viewing the content, be it a monitor or a headset. And then next is memory. Memory is a special case, motivated by the finding out about peaks being temporary switches followed by a return. Memory for us encapsulates the principle that the system needs to respond to not only their current arrangement of input and viewing devices, but what came before. These principles motivated us to represent context as a state machine. So people start in one of the green states, like desktop or VR, and then peak in either input or viewing devices, and either return back or fully switch. So say, for example, I am at the desktop. So let's put an arrow right there. So what I can do here is I can use some sort of desktop to VR peaking technique. So say something like quickly popping on the headset, or opening up a virtual view of the 3D environment, or picking up a VR controller. That would put me in this kind of peaked state. At which point I can either fully switch by kind of adopting the input and viewing devices of VR, or I can return back to mouse and keyboard and monitor and be back in the desktop state. So thinking of context as this kind of state machine really allowed us to pare down the space of available input and viewing techniques depending on where exactly in this state machine they're currently residing. So say, for example, I'm in VR with controllers and everything. I can quickly peek to desktop by opening, for example, the Steam VR menu that lets me see my Windows desktop. So this is an example of a peeking technique. It's something that lets me quickly get to information on my desktop without having to fully switch. So based on this, we decided to implement several techniques that extend this idea, like if I want to work in the VR scene but not don the headset, I can actually view and manipulate the headset's camera angle from desktop and point my controllers into the monitor for interaction. If I want to use a mouse cursor specifically, if I'm wearing the headset, I can grab the mouse and a cursor will appear in front of my face, which I can move with the mouse. Likewise, if I'm wearing the headset and I don't want to grab the mouse, I can just place my controller on my desk sideways and I can use that to control the cursor. This also works outside of VR, even though this kind of demo GIF only shows the actual thing happening in VR. There are also several ways to peek at the desktop from VR. So in addition to summoning the desktop view by tilting my hand like this, we also implemented the Steam VR panel view by default, where it's floating in the world in front of you, as well as one co-located with the physical monitor. So these techniques were put to use in a user study where people would see a math problem where one missing value was in the other modality. So say if I have a math problem like 5 plus x equals blank, and I start in VR, x will appear on the desktop monitor. This user study had two primary task conditions: input plus view, where users had to switch in both input and viewing devices, prompted by a slide to unlock task, and view only, where they just had to switch in viewing devices. Peeking techniques were either enabled or disabled depending on the condition. So we placed panels in VR at four positions in space. So the first was at the position of the virtual monitor, and the next was 1 meter above it. Another one was 2 meters to its right, or 3 meters behind it, prompting users to turn around and move in the space. As for results, we can see that peeking techniques, as denoted by the SwitchSpace bars in blue, made completing the cross-reality task faster. This is especially pronounced in the bars on the right for the condition where people switched from VR to desktop. Likewise, using peeking techniques made the cross-reality task more precise. The ability to use peeking techniques allowed the accuracy of the controllers and the mouse to be somewhat equal in terms of their accuracy in the dragging task, whereas without peeking techniques available, there was a big gap between the kind of controller accuracy versus the mouse accuracy, and which is kind of, signifies the difference between a raycast interaction and a mouse dragging interaction. So going on with this theme of precision, we can also break things down by the viewing technique that was used. The gray bars, showing cases where users couldn't use peeking techniques and had to fully switch, had a much more pronounced difference between the headset and the real monitor. This is way more reduced thanks to the peeking techniques. Also, that huge error bar in the virtual monitor technique there, it's mostly a commentary on its popularity in this task specifically. It wasn't summoned very often, meaning that the standard deviation of that error bar was super high. So now what's interesting is looking at the results for transitions. So the ability to use peeking techniques allowed people to switch between states and look between the states more often. For example, the graph on the left looks at context transitions. In both the view only and the input plus view conditions, people switch between these states more often when peeking techniques are available. Likewise, people switched input devices more often when peeking techniques were available as well. Same as that, people switched in the viewing state more often with peeking techniques. And generally, in both desktop to VR and VR to desktop conditions, the ability to use peeking techniques caused people to wear or remove the headset less. So, in summary, quick temporary peaking techniques can make cross-reality workflows faster, more precise, and more comfortable. That brings us to the end of the presentation, and feel free to email me any questions you might have. Otherwise, reach out to any of my co-authors. Would love to keep this conversation going. Thanks.